When we take a look at a picture of Mount St. Helens erupting here, it's a very impressive sight. But when it comes to mapping the same mountain, it doesn't look as impressive on a flat screen or a flat piece of paper. This is where scientists have used topographic maps to help show elevation. You'll notice and see all of those contour lines, that's what they're called, to help recognize how tall certain features of the Earth are. Other geologic features like Devil's Tower in Wyoming don't appear as impressive on a satellite image, but when we change over to a contour map, we now can start to see how tall this monument actually is, and we begin to appreciate the extinct volcano that it once was. However, when we simplify the map to something that I like to call Boy Scout camp, because it just has that appearance and the names of the peaks and things like Duck Pond, just give that rendering and impression that that's where we're at. We can start to see some of these contour lines and some of their unique characteristics. So a couple things to mention here when we're looking at contour maps and the contour lines that make up each one of them. There are a couple different things here. Number one, you'll notice that there are some bolded, darker shaded lines. Right here is one of those lines. That is known as an index contour line. Those lines give us a set number and the ability to see where we're at and what we're taking a look at. So you'll notice this one's at 1,000. There's another here at 2,000. So 1,000 and 2,000, and the lines that go in between them don't really get a chance. We don't get the chance to count them. But simple math, taking 2,000 minus 1,000, dividing it by the total number of lines, would let us know what each one of those lines represents and what the elevation for each one of those lines would be. Also, too, on this map, there's a few sections where the contour lines are very close. Circled on the page there is one. Here's another area here as well, too. There's maybe a few extra you could make an argument for, but those sections where the contour lines come very close together, that's where we're going to have our steepest change in elevation. It's going to be a real steep grade there. And again, because the contour lines are changing and they're so close together, that's a place in this map that would be recognized as very steep. And there's one other thing here as well, too, and it happens as we run through our map, and we see here that there's Zephyr Lake, we've got Duck Pond, we've got this other holding pond as well too. But in between them are a few streams, creeks, rivers. And what's interesting here is that we can actually find out what way and what direction this river or stream points due to the fact that we're able to use the contour lines. So if we take a look at these contour lines, we're going to see that they form somewhat of a V shape along the way. And that V shape actually points in the opposite direction of the water flow. So the water is not running from Duck Pond to Zephyr Lake, but in fact, the water is running and moving from Zephyr Lake down to Duck Pond, and from Duck Pond down to this other holding pond. And it probably would be safe to say as well, too, that it's going to move down even further. And there's proof, because if we take a look at these contour lines, this one is at 2,000 meters. Down below, it's at 1,000 meters. So as we go from 2,000 to 1,000, our elevation decreases. And these lines would also mean the same thing. So, the unit of this line here is going to be exactly the same right there as well too.